So hello coders, welcome to my video. So you have seen the topic of this video is stop using your own linked list and we should use sys queue.h. So whenever we talk of a linked list in C, we usually starts by creating a structure, adding a next pointer if I am using a single linked list and a previous pointer as we are using a W linked list. And then we write our own function for insertion, deletion, traversal, and memory managements. But if you are working in Linux or embedded system, then there is more interesting option like sysq.h. It provides you the ready to use macros for implementation of different type of linked list and queues without repeatedly writing the pointer manipulation code yourself. So in this video, we'll see how to use this sysq.h and how to create or transfer the linked list using the ready-made macros that is present in this header file. And if you see here, we'll see some of the topic mentioned here, like what is sysq.h, what is a problem it solved, what are the APIs to create a single linked list and a code for creation of single linked list. And last, we'll see what are the advantages and disadvantages of using this header file. Okay, so the problem we are going to solve here is we don't need to rewrite the same code or data logic again and again. So this is a simple structure that we will be using in a single list and we will overcome this structure by using some of the APIs that is already mentioned in queue.h. So the queue.h is a header file we find in most of the Linux system, though it is not been present everywhere, so that we can make it uh, default thing. But if it is not there in some system, we can port it there and use it. Okay, so it don't need anything because this is only a macros uh, APIs in this header file and nothing else. We directly include this header file in our C program and we try to use these APIs. Okay, simple as that. So this queue.h file will solve few of the linked list problem mentioned here. Okay, so first one is a list that is a doubly linked list with access from the head. SLIST type of APIs are there which will help in creating a single linked list. We have STAIL that is a single linked list tail queue efficiently in inserting at the tail. We have a tail queue like double linked list tail queue efficient in insertion and reversion at the, and then we have a circular queue for a doubly linked list as well. So these are all the linked lists that we can create by using this header file in our code and using the respective APIs. So before going forward, let's see this header file, how it looks. Okay, so we will go back and we'll open user include sys. Then we have queue.h. So we try to open this file. Let's go with the start. There is some copyright options. Okay, so it start from here, and if you go down, they will explain you few things. Like this file define five type of data structures: single linked list, list, simple queue, tail queue, and circular queue, as I mentioned earlier. Okay, so for each of the data structure option, we have relative APIs. Okay, and it is very efficient if we are using it in our code. we can use it as an closed source as well as on the open source as well. So I try to go down. You can see. So all the things are been explained in this section, and we also have a manual page for this. Okay. So if you see here, we have few of the APIs mentioned here. So I will go to, for example, here we have a list head. Okay, so this is a macro. And next we have list head initialization, list entry, so various other functions. If you see here, list init. Okay, for single linked list, we have SLIST head, SLIST entry, and other things. Okay, so I'm not going deep into this API, so better I'll open the man page for this. So once I open it, you will see the list of APIs for each of the option mentioned in that file that will implement a single linked list tail queue, list and tail queue. So these all options are being solved by this. So they have list of APIs as well mentioned here clearly. You don't need to read each and every section of that file. So better you can use this man page to understand the APIs. So if you go for a single list API, so you have these all APIs you can use to create a single linked list in your code. Okay, so I scroll down. So you have some description as well. This is just the basic of a queue.h. Let's go directly into the code and we will solve some of the problems using the APIs. Okay, so let's close this. So if you see here, I have already created a single linked list dot c. So here is our code. So the first line, if you see here, I have included this queue.h. Okay. So if you see here, we have a structure and we need to create a linked list with this structure. So ideally we have struct node and int data, and then we have struct node star next. So in spite of using struct node star of next, I am using this API. Okay. So what it will do, it will create the next entry in this linked list when you create this linked list. I'll tell you once I go to the start of this API. So first API that we will be using in our code is we have to define the head pointer. Okay. So if you see here, I have given the name of the node over here by defining this head. Okay. So next is this is a dummy structure that will create this node. Okay. And it appear as a head pointer only. So what we are doing here, we are creating a head pointer. Like if you try to think of it, how it looks. So it will be struct node list, and then we have struct node star s list, something like this. So this will be the type of the head. So I'll tell you the macro associated with it. Okay. So let's go again to that file queue.h and slist underscore head. If you see here, the first is the name of the head pointer. This will be a dummy pointer, so it will replace over here. Okay, so you can give any name to it. It doesn't matter. Okay, but if you see here, your type will be the node pointer. So struct node star of SLH underscore first. So this will define the head pointer. Okay. So next, if I go back in the main, if you see here, I have defined a struct node list first. What is this actually? As the structure is not there, but it has been defined over here. So it will take on this node structure, and the second API we are using here is SLIST underscore init, and we are giving the address of this list. So till now also it will define as a dummy pointer. Okay. So here what is the catch is we don't have uh, the head pointer as the first node. Okay, we just defining a head pointer for internal uh, data keeping. Okay, something like this. So you have defined a struct node again, and you have to give the malloc for this three pointers. So three nodes I have created. So this is not been handled by these APIs. So this memory creation and memory deletion, you should take care of this. Okay. So if you see here, as you define the mallocs, you are giving some data over this. Okay. So the data of the node is this way. And then we have a list underscore insert head. So what it does was it will add the N1 node, and this is pointed by this list. This is a dummy list, node list. Okay. So this dummy list will be pointing to the first node of our linked list along with these entries. So where we kept this entry, this is simply the next. Okay. So if you see here, list entry, node and entries. Okay. So this will revert as a next pointer. Okay. So while inserting this at the head, we are using N1, N2, and N3. Okay, so it's inserting at the start of the list. So if you start from here, N1 will be pushed first, N2 second, and third. So if you traverse it, it will be first node will be 30, 20, and 10. Similar that. And next API we are using here is SLIST for each, in which we are giving this node, and we have the address of the list and entries, and for each it will be printing the data in the node. So in our case it is 10, 20, and 30. So this all will be printed from the node, and after that we'll need to clean it up as well. For that we have to check for this list empty. If it is not empty, then check for the first node in the list, take it, remove it from the list. Here we will see like it is removing the head, okay, one by one, and moving the head to the next one. So it's removing the head and going to the next, and it's freeing the node as well. Simple as that. Okay, so after all these operations, we will be returning 0. So it means this list are created and destroyed, along with we are printing it. That's it. Okay, so just close it, and I try to compile it. Okay, it got compiled now. Now I have a S list. So if you see here, your data will be the first node will be 30, 20, and 10. Okay, as we are inserting at the start of the linked list. Okay, so I think you are clear with these APIs. If you have any doubt, just post me a comment. I'm happy to help you. So let's go for the advantages and disadvantages of using this queue.h. So if you go from the advantages, we don't need to implement this linked list operation from scratch. Instead, we are using the APIs and we are creating a linked list. Okay. So it reduces the pointer manipulation code. So what happen if you are creating is linked list from the scratch? Sometimes you have some errors you have to debug, but here you have ready-made API. You just use it and you do your work. Okay, provides a ready-to-use macro for insertion, removal, and transversal, as you already seen. Efficient and suitable for system C programming. We can use it, though we have some Wi-Fi code as well in which this will be using, and same structure can participate in multiple lists as well. Okay, so useful for Linux, BSD networking and embedded applications. Reduce duplication of the linked list implementation code. So simple as that is the main advantage is why we are using this header. Okay, so we have few disadvantages as well. Okay, so the first disadvantage is not being a part of the ISO C standard. So in some platform it will be there, and in some platforms in embedded system it won't be there. So we need to port it or something like that. Okay, so macro based APIs can be harder to debug. So this is the main problem of the macro. So it's not of the header. Okay, so reduce modification structure with list entry. We can modify our structure using the list entries. Okay, so we can create a dependency on queue.h, but if we are not using queue.h, there is no dependency at all, and doesn't need to handle memory allocation and delocation. Okay, this is a disadvantage. Obviously, we have to take care of allocation and deallocation. If you want do that, you will get some debug errors or stack overflow or anything like that. Okay, so not a thread safe by itself. So we need to create an application that is thread safe. These APIs won't handle that. So incorrect list or object lifetime can still cause memory corruption. So this is the thing. So the key takeaway of this video is your system queue.h provide a ready-made linked list macros, reduce repetitive pointer manipulation code while giving you a system level and efficient approach to linked list and C. Thanks for watching this video. See you in the next video. Thanks.